Hey everyone. So today's topic is structure of the autoencoder. Structure of autoencoder. Okay. So we have understood that what basically is an autoencoder. So we get to know that it's an unsupervised artificial neural network basically that learns how to compress and encode the data, then again learns how to reconstruct back into the original form or near about the original form. This is what the definition of the autoencoder is. Now, if you talk about the structure of autoencoder, so autoencoder is having basically four parts. It's encoder, we have bottleneck, we have decoder, and finally we have a reconstruction loss. So talking about the structure, we know that autoencoder is a set of encoder and decoder. So first we have this encoder, right? This is my encoder. And we have the decoder as well. So how it is being structured is that what happens, we simply pass the image. Let's say I'm just making some random image, okay? And that image is passed through the encoder. So your encoder, what is an encoder? So your encoder is something basically which the model learns how to reduce the input dimension and compress the input data into an encoded representation. So it takes the image and it reduces the dimension of this particular image and it compresses it. So, if I just make the output which is going from the encoder, it goes like this. So like, and here is the compression. So I'm just making it look a little bit weird because, when you reduce the dimension of the image, it looks like this only. And then it is being passed to the decoder section. So what is the decoder section? So in this, the model learns how to reconstruct the data from the encoded representation to be as close as the original input as possible. Means it again takes this encoded version and reconstruct it back into the original image. Not exactly, but at least as much as close as possible. So again, if you talk about the structures, it has the component, it has the first encoder. What is the encoder? I'm just repeating it. So this encoder is from which the model learns how to reduce the input dimension and compress the input data into an encoded representation. Now we have a bottleneck as well. So what exactly is bottleneck? So a bottleneck is, of course, one of the layers which is there inside that contains the compressed representation of the input data. So since it is the layer which is having the compressed representation of the input data, this is the lowest possible dimension of the input data. And that layer further passes the representation to my decoder. So third is my decoder. And this decoder learns how to reconstruct the data from the encoded representation to be close as the original input as possible. So it just makes it as much as looks as what it has got in the input section. And of course, how we are validating these things, I mean, how good, how bad the things are going. Well, we have reconstruction loss at the end. We have reconstruction loss at the end. So what basically this is? Well, this is a method that measures how well the decoder is performing and how close the output is to the original data. So it's basically kind of loss which tells you how much good the decoder is behaving. So the entire training involves using the back propagation that we have understood in order to minimize the network's reconstruction loss. So this was all about the structure of your autoencoder. We'll meet next time. Thank you so much.